Before I start my topic, I would like to ask to do a small survey in order to see how is your understanding of the technology to be mentioned in my presentation. I don't know how many of you have been doing the microservice. Please raise your hand. Have you ever used Spring Cloud to do the microservice? At the beginning of this year, when I first talked about how to combine Spring Cloud and Docker, I found that only a few people were using Spring Cloud. But the question I just asked, I start to see the increased number of companies using Spring Cloud. First of all, a brief introduction of Omni Prime. I am the chief architect of Omni Prime. Our company is a national leading fintech company. We have two products. One is Paymax, the other one is called Star Plan. The Paymax is facing the young blue-collar users in China to provide the consumption installment service, and the Star Plan is providing the medical cosmetics service to the young users. And then I will start my presentation. There are three parts of my presentation. First is about the reason why we are using Spring Cloud and Docker. The second part is about the process of the combination between Spring Cloud and Docker. I will talk about the challenges we have addressed. And the third part, I will talk about the prospect of the Spring Cloud use. First part, the reason or the background. Why we need to use microservice? Actually, in China, the number of the microservice is not like a large amount. For the Paymax product in our company, we have more than 1,500 microservice. The reason for us to use a microservice architecture is not only because the benefits it can bring to us. For different microservice can use different stacks. This is one benefit, but I don't think so. This is an advantage for the large-scale enterprise, because for a large-scale enterprise, they hope they can use the unified technology stacks. If they use different stacks, actually for large-scale enterprise, that's not what they want. So not all the benefits or the so-called benefits of microservice are the benefits or the advantages for different users, because actually it can increase the complexity of the whole system. For example, network latency and also distributed events. It might even make it more troublesome, and also is a very serious task or a challenge for the O&M team. So if you don't know microservice very well, it might cause a lot of troubles. The key reason for us to choose the microservice is the scaling property. Because our business is expanding and our team is expanding at a very fast pace. So how should we address this fast expanding process? So if each time we have the new members, if they have to look into the whole system, maybe it will cost like 2 to 3 months. But if we have different microservices, for each microservice, the complexity is very low. So when we have new team members on board, they can have very fast learning process for different microservice. And also it can address to the fast expanding challenge we just mentioned. And also the business is expanding very fast. Previously, we used a monolith application. So now we split into different microservices. We can have the auto-scaling and improve the GPS of the service. So this is the key reason for us to choose the microservice, which can address the challenges we are facing now during our expanding. And why Spring Cloud? It actually had some risks. The maturity of Spring Cloud might not be as good as the other framework. For example, Alibaba has Double, and Ali Cloud has EDAS. Then why don't choose Double? Because the maintenance of Double have been stopped for many years, and this year they conduct one maintenance but then stopped again. But EDAS is not an open source, so we choose Spring Cloud, which is an open source microservice framework, and it has a large community supporting it. So, especially this year, we can see a very dramatic or very fast growth of Spring Cloud. A lot of companies, they shift to Spring Cloud to do their own microservice. Of course, Spring Cloud has some disadvantages, but also it has more benefits. For example, service registration and discovery, it has a very complex solution. You can use Netflix Eureka for service registration. You can also use Console Zookeeper for the registration. And for load balancing, it supports the client load balancing. Also, you can use the load balancer provided by Alibaba. And for the client end, load balancing is a very useful thing. For example, this year, Ali Cloud had a 2 hours load balancing fault, which caused a nationwide downtime of the websites. I don't know if you have, I don't know if you still remember it. So if you use the client and the load balance, it can avoid this problem. And gateway, Spring Cloud also provided Zoom API gateway. And fuse mechanism, they use hystrix to realize it. I think this is a very good tool to. This is a very good tool for the service fuse and downgrade. And Spring Cloud also have a Spring Boot admin as the service governance center. And also we use not only Java, we also use the Node for the API aggregation. Because if we use Java for API aggregation, it's not as good as we want. Netflix has RX Java. It's better than Java for API aggregation, but a lot of people, they don't know how to write. So when you choose different technology, you need to consider the usability of this technology. Therefore, eventually we choose the Spring Cloud to construct our microservice framework. And now I would like to tell some stories during our implementation of the microservice. if you want to construct your microservice framework, it has to be a step-by-step process from 1 or 2 microservices to thousands of microservices. It's just like the growth of a company. At the very beginning, maybe in your company there are only a few people. That's very easy for the communication in the company. But when you have like 20 people, 30 people, you will establish or you will regroup your company. So in your company, there will be a different team, and for each team, it has a team leader. So when you need to communicate with the whole company, you have to go through the team leader. And when the company grows to like 100 and 200 people's company, and you will have different departments like R&D, number 1 R&D department, number 2 and number 3. And then under each department, you will have different teams as well. So you will have the architecture or different organization structures in the company. So it's just like the microservice framework development process. So when you have only 1 or 2 microservices, it poses no problems. But when you have like tens of microservices or hundreds of microservices, the invoke relationship between different microservices will be a network. That will be a very complex network for you to manage and to invoke. In our company, there are 300 microservices. As the chief architect, I still cannot tell the purpose of each microservice because now the microservice framework or the network has been very complicated. It's just like your company have 300 people. Can you remember the name of each person? It's the same thing. So we have a layered principle. So the upper layer service can call the lower layer service, but the lower layer cannot call the upper layer. You have to use queue to notify the events on the upper layer service. And also we have a regrouping principle and also single access principle. For example, we have 10 microservices as a group, and the API gateway is the team leader. So all the services within this team will be exposed through one API gateway.
So when I do the layering, then you only look at these teams, and then it simplifies the issue, and it's easier for the leader to remember even he has a bad memory. So through the grouping and the layering, it can reduce the complexity of the microservices and really get the calling principles straight. And when you want to do management and monitoring, it's much easier. And this show you the metadata of the. This show you the result of the layering, and you can see the first is the connect layer, and you can use it use the API gateway to access the business layer, and also there is an API integrator because every microservice is very kind of isolated and segregated. If you want to call it, the front-end logic will be very complex. So you use this integrator to combine these microservices, and then the result will be fed back to the front end. So the caller will feel it's easy. So this is API integrators the role. So in our entire system, we have a lot of API integrators. It can reduce further the complexity of microservices. So you can see the structure now. And every layer has a Zoo API gateway as the major access point. And is that okay when we group and the applications? But as we say, we have 300 people. You have to go to find them, right? And what we do is we go to the Outlook address book and find the person, find its information. If I can find it, then I can find where his seat or what's his phone number. Then I can call him. So it's the same with the microservice. When you have over 300 microservices, even thousands of microservices, then you have to maintain the metadata of these microservices, and for you to manage. So the metadata of the service is very important. This is why we say you have to use a service register and the discovery system. It's not that you just send your IP address to the registers. It's just too simple. The point is it sends all the metadata of the service to the registry. For example, the team layer of this microservice, why we say that we have to do layering, because only the top layer could call the bottom layer. And if a developer wants to call another layer, if you cannot limit it in your RPC, then you cannot really manage manually. You can formulate all the regulations as you want, but they won't solve the issue. And also, the metadata include the name of the service, the version of the service. So when you do RPC calling, I look at your layer, I look at the called service layer. If it is layer 1, my layer is layer 2, then that means you're calling the upper layer, and the call will be failed. So even the developer want to violate the principles, they can't, because the result will be failed. That's why we have to register the metadata of the service, because they can do a lot of things. I was just giving you the simplest example. And when we talk about the microservice, we did a lot of scaling based on Spring Cloud. And when we use Spring Cloud, we also want to Dockerize it, because Docker and the microservice is really complementary to each other. And honestly speaking, I also feel that when we talk about the benefits of the container, sometimes as like a or fake benefits. They are not necessarily fake. They're not necessarily true benefits. For example, Docker can allow fast deployment. I don't really agree with it. And ECS can achieve faster speed, because if you use ECS, I can do packaging firsthand. Then I will just copy the package. It's just dozens of MB, so it's very small. For Docker, I have to I have to use the tag, etc. So the early cloud Docker aggregation, they cannot achieve a parallel deployment. So this is an issue. Maybe previously, if the image is parallel deployed 2 or 3 minutes. If you use container, maybe it's 40 minutes. But for single service, the difference is not that huge. So for microservice, you have to be very clear to think it from a larger perspective. If you look at a single service, maybe a lot of benefits. But when you look at the entire landscape, then the benefits could be false. And why I want my company to do containerized? Because container can really provide a consistent and a replicable environment. Previously, when we use ECS, it's very complicated. One ECS is a 4 kernel and 8G. And the problem is one service increases the CPU and the other services is non-accessible. So the segregation of the service is lost. Or with ECS, I put on some beta testing, and some developers can make mistakes. For example, they cannot access the core stack. So using containerization, we can provide a consistent and replicable environment. I think this is the greatest benefit for us. I think this is the greatest kind of benefit. And then it allows elastic scaling. And it's not easy. But if you use container, it really makes scaling much easier. Use Ali Cloud container technology. It's just as simple as you change the value, change the number. You just maybe replace 2 with 4 or 5. But actually, it's easier to scale up compared with scale down. So as I say, scale up is easier, but scale down is not so. And also, they provide a rolling update or rolling deployment. And of course, this also has some what we call traps that you have to avoid. For example, when you Docker do a print image, they always print like the latest image. You didn't want to deploy it, but it is already there. Then it resulted in issues. You deploy things that you don't want to deploy. So for Dockers, you don't want to tag with latest. So this is green and blue release. You have to put a version number on every image. Or when you upload image, one is tagged with latest, one is not. So this is why we want to do the containerization. Of course, there's still a lot of challenges. This is just some simple kind of challenges. The large amount of the microservices, the large workload of the testing, and you can see that from ECS to container, the business logic is not changed. But from the testing perspective, the change is enormous. And they feel the entire business should be tested again. You have to do a full regression, so it's very precious work. Do you feel it's logical? I think yes. And also, you won't able to see short-term benefits. When you use Docker, the benefits is really on the operation and maintenance side. For general developers or for senior or staff and executive of the company, it was not ominous or short-term benefits. And also, when you do containerization, you can only do it step by step. You have to, this definitely will involve the coexistence of inside the container and outside the container. So what we do is what I'm going to talk about now. So actually, there's a lot of concrete stuff, really my first-hand knowledge and experience. So now I will give you the process. This is a very laborious and hard-working process. And I can see it's a history of sweat and blood. And now maybe I will talk about the CI/CD pipeline. So we've reconstructed the CI/CD pipeline, and the question now came. Now, when we use Ali Cloud, the container environment of Ali Cloud, we use their mirror service, and when we use their benefits is that it's in their database, so it's easier to get the mirror data. But the Ali's RAM cannot integrate with our AirDAP. So you must have the pre-account. I cannot create an individual Ali account for everyone. So the problem is really very frustrating. So when we really implement it, you can see we have GitLab premise mirror. We also have Ali's premise, Ali's mirror service. So what we do is we create and require release to the branch, and then the webhook will give a notice. Then we will build and orchestrate and detect the static code to the unit testing, to the integration testing, and then we will upload the Docker image to the GitLab's mirror storage. And then we will also upload it to the Ali Cloud mirror service. And the GitLab's mirror service is really for the developers because they integrate with LDAP. And I can ask all of my developers to get these mirrors from GitLab.
So this is the first difference between us and the others, the double image. And for others are very similar with the CI/CD and the pipeline, so I will not spend too much time on it today. This is our imaging management. In image management, when we have the double image, we also have some requirements for the image. For the code registry, we also have requirements. I believe that a lot of companies are using Jenkins as the CI/CD pipeline. The new Jenkins, the new version of Jenkins just introduced the pipeline, but this pipeline function just came out in the new edition of Jenkins. So actually, we are not using Jenkins with GitLab pipeline. Our CI/CD pipeline is described as the point press document of GitLab. So if you haven't seen the CI/CD pipeline of GitLab, maybe you can have a look. It's similar with Jenkins pipeline. It's a CIS code, CDS code. So for the programmer, for the developer, we don't hope that the Jenkins configurations like this server configuration will have to configure another server manually. This is not what the programmers should do. We did once, and then after that, it should be okay. We just have a unified or standard method to do that. Therefore, for the CI/CD pipeline, we regard it as a code to manage and submit to the image registry. In one code registry, only one microservice. So one microservice, only one CI/CD pipeline. Therefore, we have done some work on the code pipeline. After the improvement, and we need to deploy on the Ali container. And the Ali container, they also have their own terms. For example, they have the cluster concept, application concept, container concept, service concept. So we have to map our own concept to the Ali cloud container. Therefore, we map our service concept to Ali Cloud service concept. And the second concept is the application. For Ali Cloud Swarm cluster, because Ali Cloud Container Service is based on Docker Swarm or is compatible with Docker Swarm. So one application is Docker Compose document, which has several services. So one application corresponds to one group, which has one API gateway as the output or as the outlet. So we can use the cluster to correspond our production line or product line. So we map our microservice framework to the Ali Cloud Container Framework. When we migrate to Ali Cloud Container, it's a step-by-step process. So one part of the application are in container, and some applications are out of container. But when you have part of applications in the container, part of the applications out of the container is very difficult. The biggest trouble is the network. Docker abstracts the network. After the abstraction, the old IP address is in the network. It doesn't have anything to do with the EPS. And for the ordinary ECS address, if they want to visit the IP address within the Docker network, it cannot be done. So this is also the challenge that we are facing. In order to complete a smooth migration, we have done a lot of adjustment. First one, for applications, the service registration and the discovery, as I just mentioned, we need to register the service to the service registration server. We use Eureka server. And also, we need to register the extra service. The most important thing is the IP address. When you call the service in the future, you will not use the IP address. Instead, you will use the service name. Because the address in the container, it is changeable. Because after the deployment, maybe the address might change from 1 to 2. Therefore, when you call the service in the future, you cannot use the IP address. So in Ali Cloud Container, they have its own framework or the solution for this containerization process. But it still cannot meet all of our demands, because for each service you only know the IP address is not enough. You need to know the source information of the service. Therefore, we didn't use the container service registration and the discover mechanism. So we still use our own Eureka service registration and discover mechanism. So you can see the green dotted line. We registered our service into the Eureka server. When the A service instance want to call the B service distance, we have a ribbon plugin. is a client load balance component, so it will visit the Eureka server and find all the IP address and the source information of these services based on the service names. So the Spring Cloud Eureka Cloud will cache these services every 30 seconds. Therefore, this is the service registration and the discovery mechanism. So we can use ribbon to find the corresponding IP address and shift to the service. And for the cluster, within the cluster we have a grouping concept. We hope that each group has a fixed outlet, visit in a fixed inlet. Each service has to register its own IP address in the container. Also, it has to register its group name. And according to the group name, you can find the address of the API address. And we use the ribbon to expand. We find that when a service is called the service from another group, we need to find the group name first. And also the API gateway address of this group. After you find it, you send the request to the API gateway, and the API gateway will forward to the corresponding service. So through this approach, we can realize the cross-application service invoke within the cluster. And what about the invoke between the container, in container and out of container? We can add a load balancer on the API gateway. The API gateway registering its own address will register both addresses in the container and on the load balancer. One is in ECS, one is in the cluster. So when we call the services, we can use the load balancer address to address the issue. So we can see that the Spring Cloud has been expanded in our case. Also, we did our own grayscale launch. Omni Cloud also support the blue and the green launch, but it can only realize the blue and the green launch at the application level instead of the enterprise level. It's also expansion of the ribbon and an API gateway based on the HTTP header, and you put on tag and you can have a grayscale launch solution. And now let's look at about the elastic scaling of the container. Under many circumstances, it should be based on queued size. If you use the Ali Cloud Container Service API, you can realize this. You can monitor the queue side and also the scaling up API. For monitoring, the monitoring in the container of Ali Cloud only monitors CPU, memory, I/O, and the network. And for the other monitoring, it cannot realize. So maybe we can add the Zabbix in all the basic images and use the Zabbix to monitor the container status. For logging in the container, It's not a continuous. So we can use the stdots to output the log and avoiding using the data volume. And also we can put all the log on the control panel, and then the Ali Cloud control will collect all this log and public on the Ali Cloud, so you don't have to store the log on your hard disk. Another thing is about the network. Docker actually has a number of bugs. There's one big bug. It's network bug. The network does not converge, which means the network of the two containers cannot be connected with each other. Therefore, we are in the communication with Ali Cloud, and Ali Cloud is also in communication with Docker, trying to solve this bug. If we use the EPC, this problem will not exist anymore. And how can we realize the seamless migration? We use one ECS environment and one Docker environment. So we can use incremental migration to the container environment, and also the same service in the container and out of the container. We can have two sets of deployment, and using the load balancing to do the streaming cutting based on a certain proportion. And during the migration, we have met a lot of obstacles. For example, the network overlay convergence, because it is a bug of Docker container itself, so Ali Cloud cannot do much about it. So I think if it hurts, do it more frequently and bring the painful wall. So when you are when you encounter an obstacle and you have to do it more frequently, try more.
The other thing is the best way to avoid failure is to fail more. So basically, that the greatest way to avoid big failure is to fail at smaller tries. So you will of course run into a lot of traps, but this trap will not hinder your way toward success. And in the end, I think we are confident to work with Ali to achieve the containerization of all of our microservices. That's all for my presentation. Thank you. So, any questions for Mr. Li? Just time for one question. Thank you. I have a question. You talk about the traffic switch 5%, and then the Docker system malfunctioned. So is your data implemented? How do you process the data when you switch back the dock? If you don't use dock, how about the data? And even the containerization, we containerize the service. We don't containerize database. So even ECS, but they have the same DB. So when I switch the traffic, the database is still there. So it's just containerize your web, containerize our microservices, and the database is not containerized. Okay,